This Mars Hydro SP3000 LED grow light has been a great help for my tropical plants during winter. I had enough time to put it through various tests, so as promised in this video I'll be reviewing the features of the Mars Hydro SP3000 grow light and more importantly discuss its performance, looking at heat output, power consumption, power values and overall efficiency based on tests performed not just at its maximum output but over the entire dimmer range. This is what you get when you order the SP3000, so let's get this open and see what's inside the package. First, there's the user manual, which I found to be too generic as it's intended to serve as a manual for various Mars Hydro grow light models, with some instructions not applicable to the SP3000. There's a lot of foam padding that needs to be removed to get to the light, and this is a good thing since the light fixture is protected on all sides by several thick pieces of foam, which means the package should be able to withstand quite a bit of mistreatment. An RJ11 telephone cable is included to facilitate daisy chain operation of the light dimming control for multiple grow lights. There's also a hanging kit which includes the hangers, rope and ratchet pulleys required to hang the light. And finally, here is the grow light itself. The light fixture has a long rectangular shape, which is why it's recommended for a 60 by 120 cm or 2 by 4 feet area. To protect the surface mounted LEDs, there's a final layer of foam and a large piece of plywood placed at the bottom of the box, which should keep the LEDs safe during shipping. The SP3000 seems to be very well built. The LED board has a water resistant coating. With an overall IP65 rating, the grow light is well suited for high humidity environments and you don't need to worry about accidentally spraying it. It features Samsung LM301B LEDs for a mixture of warm and cool light and Osram 660nm LEDs to cover the deep red area of the light spectrum. The LEDs are powered by a top quality Meanwell ELG300 driver mounted on the top of the fixture. A dimmer control which is connected to the driver can be used to adjust the light intensity in the 10 to 100% range. It also allows connecting multiple lights together to be controlled from a single dimmer box. The main body of the grow light is essentially one large radiator which is required since both the LEDs and the driver produce a lot of heat, as you will see in the heat test. The two hanger pieces hook on the black top plate. I hooked mine at the ends of the grow light in the slot that's made right next to the logo. Then you just pass the hangers to the carabiners and use the ratchet pulleys to adjust the hanging height. While looking for performance data, I found that the product specification as well as independent test reports mostly focus on the maximum grow light rating. While using the SP3000 at the maximum brightness level is recommended in some cases such as the flowering stage for some plants, the specs from the Mars Hydro website indicate that the light should be dimmed down to 50% for vegetative growth and 25% for seedlings. However, there isn't much performance information for the grow light at this level, so I decided to perform my own tests over the entire dimmer range. Even if Mars Hydro sponsored the channel with this grow light, data presented in this video represents my real, unbiased test results. I started by performing heat tests, which are important if you're using the light in a grow tent. For heat measurements, I used a multimeter equipped with an external temperature probe. First, I taped the probe to the driver and measured the surface temperature for the entire range of light levels by adjusting the dimmer scale. For all tests, the light was allowed to function for 1 hour after each knob adjustment before performing measurements. The driver temperature stayed between 35 degrees Celsius or 95 Fahrenheit with the dimmer turned all the way down, and 60 degrees Celsius or 140 Fahrenheit at full light intensity. Then I repeated the measurements with the probe mounted on the LED board. The temperature of the LED panel stays between 27 degrees Celsius or 81 Fahrenheit and 51 degrees Celsius or 124 Fahrenheit, which is almost 10 degrees lower than the driver temperature. The top side of the radiator stays slightly cooler than the LEDs. I measured 46 degrees Celsius or 115 Fahrenheit when the light was set to the maximum output level. But how does all of this influence the actual temperature inside the tent? I made some tests using my 60 by 120 cm or 2 by 4 feet tent, with the light hanging 1 meter above the bottom and a thermohygrometer placed 40 cm or 18 inches below the light, where the top of the plants would normally be. With the tent door open, temperatures stay between 24 and 27 degrees Celsius. Closing the door gets the temperature between 26 and 30 degrees with the lower vents open, and up to 33 degrees when all the vents and ducts are closed. One of the features of the SP3000 is that the driver can be detached and placed outside the tent. So I removed the driver and dimmer box from the light chassis and repeated the tests to see how much of a difference it would make to have the driver outside the tent. It turns out the difference between having the driver in the tent and having it outside is limited to a few degrees. It would seem that the heat generated by the driver is not enough to increase the temperature inside the tent considerably, at least not within a few hours. So taking the driver out of the tent doesn't seem to help much for regulating temperature. Next, let's look at power consumption. I used the power plug meter to measure the power draw of the SP3000 at various light intensities. As shown by the plotted measurements, power consumption ranges between 40 watts on the low end and 277 watts on the high end. If you're wondering if that's a high power draw, think of it this way. The highest power draw of the SP3000 will be a bit higher than the power consumption of an average energy efficient fridge, but lower than other appliances such as a vacuum cleaner or a washing machine. The 277 watt maximum power draw I recorded is a bit lower than the 300 watt plus minus 5% indicated in the specification. This might be caused by recent changes in the electronic design of the grow light. One such change is the exclusion of the deep blue LEDs, which are not present in my version of the light, but can be clearly seen in this video made by Shane from MyGrow in March 2021. Shane's channel is all about grow light technology, so I recommend his videos if you want to learn more about grow lights. I'll leave a link to the MyGrow channel and Shane's video on the SP3000 in the description below. To replicate grow tent conditions, I performed the part test inside my 60 by 120 cm grow tent. Note that reflection is not ideal in the lower part of the tent due to the black zipper backing and edges around the vents, so I expect the par values to be a bit lower than those measured in an enclosure with uniform wall reflectivity. I marked a grid on a black non-reflective material and placed it on the bottom of the tent. Each square in the grid has a 15 cm or 6 inch side. PPFD readings were made using the Photon app with the LED full spectrum setting on a first generation iPhone SE. While the Photon app is not a certified light meter, it was proved to be accurate down to a few percents when compared against a professional quantum par light meter. Slight deviations from true par values do not affect relative measurements, which I am using here to compare the performance at various hanging heights and different light output levels. In case you're interested, there are some good videos presenting part test results obtained with a quantum par light meter and focusing on the light performance at full intensity. One is Shane's video on the MyGrow channel, which I mentioned earlier. The Dr. MJ Coco channel also features the SP3000 in 2 videos covering part tests and investigating various hanging heights and coverage areas. You can find links to these videos in the description field down below. In preparation for testing, I covered the camera with a paper diffuser as required and calibrated the app. I centered the grow light inside the tent and leveled it at the first test height of 41 cm or 16 inches. Then I started taking the PPFD readings required to build par maps corresponding to the 25, 50, 75 and 100% dimmer settings. At this hanging height with the dimmer set to 75 and 100%, we get an average PPFD of 610 and 858 micromole per square meter per second respectively, which is good for plants with very high requirements in terms of light, although the center area might get too much light when the dimmer is set to 100%. At 50%, we get an average PPFD of 387 micromole per square meter per second, while at 25% the PPFD gets down to 245, which are good average values for most houseplants with moderate to high light requirements. Raising the grow light at 46 cm or 18 inches improves the uniformity of the light spread but reduces the average PPFD by 4 to 5% for the 2 lower settings and 7 to 8% for the higher settings. At 51 cm or 20 inches, we get another 5% drop in the average ppfd for the 100% setting and less than 1% for the 75% setting. At 50 and 25%, we get a slight increase in the average ppfd, which is most probably due to the increased average reflectivity of the tent walls, since we gain some additional reflective surface by raising the light. In terms of photon efficiency, the SP3000 performed well across all test cases. The lowest efficiency value of 1.98 micromole per joule was recorded with the light at full intensity, hanging at 51 cm, while all other values were larger than 2 micromole per joule. An interesting aspect is that the efficiency seems to be lower when the light runs at full intensity. This suggests that you could get better efficiency by hanging the grow light closer to the plants and dimming it down. The only downside I can see is that lighting uniformity decreases as you lower the light, which means you can have hot spots. Overall, I'm pleased with the performance of the SP3000 and I found the test data I gathered to be helpful for setting up the light. I hope this video was also helpful for you, and if you wish to find out something that I may have missed or want to share your thoughts, please leave a comment down below. Thank you for watching, I'm Stefan and I'll see you in the next Odd Bonsai video.